All right, let's talk about something every single developer runs into: how to handle data in your app. In any modern app, you're pulling data from everywhere, from APIs, local databases, maybe some caching, and if you're not careful, things can get messy fast. Your core logic can turn into a tangled web. Let's actually look at what that chaos looks like. So does this look a little too familiar? You've got your main business logic, the brains of your app, and it's trying to talk directly to a remote API, and a local database, and maybe an in-memory cache. Each of those things has its own set of rules, its own way of working, and your code ends up having to know about all of them. It's fragile, it's a nightmare to test, and trying to change anything feels like you're performing surgery. And this is how we fix it. It's night and day, right? On the left, that's the chaos we were just talking about. But check out the right side. We've introduced just one single layer in between, the repository. And just like that, everything is clean and orderly. Now, the business logic only has one place it needs to go to get data. It has no idea where the data is actually coming from, and you know what? It doesn't need to care. That's the beauty of good architecture.
So what is this magic component? Well, it's a classic software design principle, and it's called the repository pattern. You can think of it as being your app's official data mediator.
Okay, so here's the more formal definition. The repository pattern is just a layer that sits right between your app's brain and all those messy data sources. Its only job, its entire purpose in life, is to manage data access. It fetches data, it saves data, and it completely hides all the complicated, messy details from the rest of your application.
So you might be thinking, okay, but why add this extra layer? Is it really worth the effort? Oh, for sure. The payoffs are huge. And they really boil down to 4 key things that are going to make your life as a developer way, way easier. And what's really cool is how these benefits all build on top of each other. So first up, decoupling. Your business logic is totally separate from how the data is stored or fetched. This means you could literally rip out your old database and plug in a new one, and your business logic wouldn't even blink. That separation leads directly to centralization. All your logic for fetching data, the rules like, hey, check the cache first, then try the database, and only if that fails, hit the API. All of that lives in one single place. It's so much easier to maintain. Third, and this is a big one, testability. When you want to test your business logic, you can just give it a fake or mock repository that spits out predictable data. You don't need a real network connection or a database at all. And finally, abstraction. You get to hide all the nitty-gritty details of libraries like retrofit or room. The rest of your app doesn't need to know anything about them.
All right, that's enough theory. Let's see what this actually looks like in Kotlin. And you know what? It's surprisingly simple. It really just comes down to 3 basic steps.
So here's the game plan. First, we'll define the shape of our data with a model. Next, we'll create the contract using an interface. And finally, we'll write the actual code that does all the work in the implementation. Let's break them down one by one. Step 1 is the easiest part for sure. We just need to define what our data looks like. In this case, we're making a simple user object with a Kotlin data class. It's got an ID and a name. That's it. This is the little bundle of data that's going to be passed around our whole system.
Now, this is maybe the most important piece of the whole puzzle, the interface. Think of it like a contract. It defines what our repository is capable of doing. Here it says we can get a user by their ID, and we can save a user. But notice what's missing. There's nothing in here about how it does that. No mention of an API, no database, nothing. This is the heart of the pattern.
And finally, we get to the implementation. This class, user repository implement, it makes a promise to follow the rules of that user repository contract we just made. And inside the getUserById function, you can see the logic we were talking about earlier. It first tries to find the user in the local database. If it's not there, and we can check that with that slick little Z Elvis operator in Kotlin, then it goes out and fetches the user from the remote API. All that complex logic is neatly tucked away right here.
Okay, so we've built our repository, we're feeling good, but how do we actually use it the right way inside our app? Well, there's one golden rule that you absolutely have to follow.
And there it is. This is one of the most fundamental ideas in good software design. What it means is the rest of your app should only ever know about the user repository interface, the contract. It should have no idea that a class called user repository imp even exists. You always program against the contract, not the messy details behind it. And this right here is the beautiful result of all that work. Just look at this user profile presenter. When it's created, it just asks for something that follows the user repository contract. It doesn't ask for user repository implemel, and it doesn't care about it. This makes our presenter totally decoupled.
For our tests, we could give it a completely fake repository, or later on, we could build a new implementation that uses a brand new backend. In this class, it wouldn't have to change by a single line of code. That right there is clean, maintainable software.
So there you have it. We took a complex problem and built a clean, testable, and centralized data layer. We've tamed the chaos. But in the real world of app development, there's one more piece to this puzzle we need to think about. Now, for the sake of keeping things simple, all of our examples were synchronous. But we all know that network calls and database queries can't happen on the main thread. They'd freeze your app. So the next logical step is to make all of this work asynchronously. And that leaves us with a great question to chew on. Now that we've got this powerful structure down, how do we adapt it to work seamlessly with modern tools like Kotlin coroutines? Well, that sounds like a great topic for another time.